Today we're going to be learning how to simplify radical expressions. There's a few key ideas behind this. The multiplication property of square roots states that the square root of AB is equal to the square root of A times the square root of B, as long as both A and B are greater than or equal to 0. This allows us to take something like the square root of 24 and rewrite it as the square root of 4 times 6, which by the multiplication property of square roots is also equivalent to the square root of 4 times the square root of 6. The other key idea we'll use is that square roots and squared powers are inverses, so the square root of x squared is just x. Let's look at an example quickly. The square root of 25 can be rewritten as the square root of 5 squared. Since the square root cancels out the squared power, this is just 5. So how do we know that a radical is simplified? We say a radical is simplified, or in its simplest form, when the value under the radical has no square factors. And as a bonus, we'll have the smallest possible number under the radical, which makes it easier to work with. Great! Let's try some examples to see how to get rid of those square factors. For our first example, we want to simplify the square root of 20. To start, we'll want to break down the number under the radical, 20, into its prime factors. So we're looking for prime numbers that multiply to give us 20. 2 times 2 times 5 equals 20, and 2 and 5 are both prime numbers. Great! Now we're trying to simplify. We'll look for the factors that can be rewritten as a number with an exponent of 2, as those will cancel with our square root. So let's rewrite the radical as the square root of 2 squared times 5. We can now split this up as the square root of 2 squared times the square root of 5. The square root of 2 squared is just 2, so we get 2 times the square root of 5. We can write that as just 2 root 5, which is our final answer. Great! Let's try another. For our second example, we want to simplify 10 times the square root of 75. We have a coefficient of 10 in this example, but we'll still start by finding the prime factorization of the number under the radical, which is 75. 75 is equal to 3 times 5 times 5, which are all prime numbers. Next, we'll look for any perfect square factors. 5 times 5 can be rewritten as 5 squared. Then we can break up our radical to rewrite our whole expression as 10 times the square root of 5 squared times the square root of 3. The square root of 5 squared is 5. And lastly, we'll want to multiply our coefficients 10 times 5 to give us 50. So 50 root 3 is our final answer. Awesome! One more example. We want to simplify 4 root 294. Let's break the number under the radical into its prime factorization. Since 294 is a large number, let's break it down piece by piece. I know 294 is equal to 147 times 2, and I know 147 is equal to 49 times 3. Then 49 is equal to 7 times 7. Since 7, 3, and 2 are all prime, 7 times 7 times 3 times 2 is the prime factorization of 294. Now let's look for our perfect square factors. 7 times 7 can be rewritten as 7 squared. Let's break up the radical to rewrite our entire expression as 4 times the square root of 7 squared times the square root of 3 times 2. Now we can simplify the square root of 7 squared to just 7. We can multiply our coefficients 4 and 7 to give us 28. Since the square root of 3 times 2 won't simplify anymore, we can multiply 3 and 2 back together. So our final answer is 28 root 6. That wraps up our tutorial. Keep up the good work.